their derivatives because this is calc and that's what we do. Let's say I have y equals arctan of x. And I want to find the derivative of that. Well, one thing I know is that if y equals arctan, that means tan of y is equal to x. And this I can take the derivative of. I know everybody's derivative. Derivative of tan of something is secant squared of that thing times its derivative. The derivative of x is 1. So, solving for dy dx, I get 1 over secant squared of y. But I can't leave it in terms of y. I have to write it in terms of x because those are the rules. So, I'm going to look at this factoid. If I know tan of y is x, I'm going to draw a triangle with that information in it. Here's y. Tan is opposite over adjacent. Well, I can think of this x as x over 1, so opposite over adjacent. Using the Pythagorean theorem, a squared plus b squared equals c squared, I get the third side to be the square root of x squared plus 1. Now, reading the triangle, secant is the square root of x squared plus 1 over 1, because secant is 1 over cosine, and I'm squaring it, so I get x squared plus 1. So the derivative of arctan is 1 over x squared plus 1. Cool. Let's do another one. Let's do cotan. Y equals arc cotan of x, which means I have cotan of y is equal to x. Taking the derivative, cotan of y, derivative is negative cosecant squared of y times dy dx. So dy dx is negative 1 over cosecant squared of y. Setting up my triangle. Cotan is adjacent over hypotenuse, so I get x here and a 1 here. Sorry, adjacent over opposite, so nothing. Making the third side, Pythagorean theorem, the square root of x squared plus 1. Cosecant is 1 over sine. Sine is 1 over this, so cosecant is the square root of x squared plus 1, and I square it, and I get negative 1 over the square root of x. No, I don't. Negative 1 over x squared plus 1. Notice it's the same thing, but negative. And this is going to be true for all 6 of the arc trig functions. Oops, I lost it. All 6 of the all 3 of the inverse trigs that start with a C. They're just going to be negations of the other one, of that the co-function it is of. Oh, that's harder English. Let's do sine. If y equals arc sine of x, that means sine of y is equal to x. I'm going to go ahead and draw my triangle because I know I'm going to need it. Sine is opposite over hypotenuse. The Pythagorean theorem tells me, why aren't you focusing, that the third side would therefore be the square root of 1 minus x squared. There we go. Doesn't like my hand. So taking the derivative of sine is, derivative of sine is cosine. Tongue-tied today. Dy dx equals 1. So dy dx is equal to 1 over cosine y, which, looking at my triangle over here, cosine of y is the square root of 1 minus x squared over 1. So we get 1 over the square root of 1 minus x squared. So the derivative of arc sine is 1 over the square root of 1 minus x squared. And what I was saying before, when I got all tongue-tied, the derivative of arc cosine, if we were to crank it out, we would get the same thing but negative. last one, or last two, y equals arc secant means that secant of y is equal to x. Secant, which is 1 over cosine, means I have an x here and a 1 here, making the third side x squared minus 1 using the Pythagorean theorem. Now, using this, I'll take the derivative. Derivative of secant of something is secant of that, tan of that, times dy dx, and that has to equal 1. Simplifying, or solving for dy dx, I get 1 over secant y times tangent y. Looking at my triangle, secant y is x, and tan y is the square root of x squared minus 1. So we have, finally, the derivative of arc secant of x is 1 over x times the square root of x squared minus 1, and the derivative of arc cosecant is negative 1 over x times the square root of x squared minus 1. So those are the derivatives of the 6 trig inverse functions.